Okay, so let's try this question from the October-November 2023 5-2 paper, question number 6. Let's try this tricky question. In a restaurant, tables are rectangular. Each table seats 4 people, 2 along each of the longer sides of the table. 8 friends have booked 2 tables, X and Y. Rajat, Zoo, and Tan are 3 of these friends. The 8 friends will be divided into groups of 4, two groups of 4, one group for table X, one group for table Y. Okay, find the number of ways in which this can be done if Rajat and Sue must sit at the same table as each other and Tan must sit at the other table. Now, one thing that we should read very carefully, we're talking about division into 2 groups. Number of ways in which we can divide these 8 people into 2 groups of 4, given that Rajat and Sue are sitting at one table and Tan is sitting at the other table. So this is a combination problem. So what we do over here, let's redraw this over here. We have 2 people booked or already selected for table, let's call that table X, Y. Rajat and Sue, let's say for example, they have already been selected and Tan is on this table. There's another possibility that Rajat and Sue are on table Y and Tan is on table X. So Rajat and Sue. Now, if we try to see this, when we have this case over here, oh sorry, Tan over here, Rajat and Sue over here. Now, when we have this case over here, 2 people on table X have already been selected and one more person from Y has been selected. So this means that out of 8 people, 3 have been selected. So we are only selecting from a pool of 5 people. So out of those 5 people, we need to select 2 people for the table X. That means 5C2. And one person is already selected. So that means we need to select 3 people. So how many people are left after table X has been filled? That means 3 people are left. So 3C3. This case will be identical. So this means that we just need to times this by 2. So these 2 cases are identical. So 5C2 times by 3C3 times by 2, we get 20. Right. When the friends arrive at the restaurant, Rajat and Sue now decide to sit at the table X on the same side as each other. Tan decides that he does not mind at which table he sits. Right, okay, again we have different cases over here. One case is that Rajat and Sue are at this side of the table, and the other case is that they are at this side of the table. So this means that there are 2 possibilities over here. They will be identical as we'll see over here. For this one, Rajat and Sue may interchange places, so these internally they will have 2 factorial or just 2 possible permutations. Now they're asking for different seating arrangements, so this is a permutation problem. And for the rest of the 6 people, there is no restriction. So rest of the people can be in any placement. And since this scenario, this scenario is exactly identical as the first one, so that means we'll just times it by 2. So 2 times by 2 times by 6 factorial, we get 2880. Now there is another way we can do this also. Now if let me just copy this and let me show you another way we can solve this. Right, okay. So if we now take a look again, the two possible choices for two possible arrangements of R and S, they are 2 factorial each. So 2 factorial each. And for the rest of the two places on table X, we have to choose from 6 people now, right? So 6p2. And then how many people are left? 4 people are left. So 4 people are left, so just 4p2. Oh, sorry, 4p4. And since this scenario is exactly the same, so it'll be just times it by 2. So 2 factorial is 2, so basically just 2 times by 2 times by 6p2 times by 4p4. Oh, sorry, 4. So this is also equal to 2880, same as what we found above. Alright, as they leave the restaurant, the 8 friends stand in a line for a photograph. Find the number of ways of different arrangements if Rajat and Sue stand next to each other, but neither is at an end of the line. Right, okay, so now for this part also we can do it 2 different ways. Both are fine, so it's up to you how you choose. So now when we make for 8 different places, a 1 2 3 4 5 6 7 8. Now Rajan and Sue are considered as one unit because they're standing next to each other, so we'll just combine them into one. So, and since Rajat and Sue can have 2 possible permutations internally, so this is just 2 factorial that we write over here instead of this. So this is Rajat and Sue over here. Now these two over here, since they can't be at the end, this means that if we make just how many are there left? 6. So 1 2 3 4 5 6. All right, so let's just make over here. So if they can't stand at the end, so this means that they can be over here, 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 and here. So this means that 5 choices for Rajat and Sue times by 5. And for the rest of the 6 people, there is no restriction, so 6 factorial. So 6 factorial times by 5 times by 2, we get 7,200. An alternative way for this is that we find out how many times, like how many waves Rajat and Sue are standing next to each other, and then subtract from that the arrangements when they are at the ends. So let's look at an alternative. So when they're standing 1, 2, 3, 4, 5, 6, 7, 8. There are 8 people, right? Yes, 8 people. So when they are together, simply just Rajat and Sue, we have how many units? 1, 2, 3, 4, 5, 6, 7. So this means that 7 units times by 2 factorial when they are together. So when Rajat and Sue are together, right? But since we do not want them at the ends, that means how many choices do we have? So let's map out when they are, or the number of possibilities or number of the arrangements when they are at the end. So for example, if we make this end over here, so Rajat and Sue. So now when they are at an either end, 6 people left over here are unrestricted. 2 factorial for the internal permutations of Rajat and Sue, and times by 2 because the same arrangement can be on the other end also. So this subtracted with this. So this is Rajat and Sue at ends. So let's see what answer do we get. 7 factorial times by 2 minus 6 factorial times by 2 times by 2. We get the same answer, 7,002. All right, so see you at the next question.